So, as I mentioned earlier, we're going to be looking at the Energy Manager application within the Mindsphere service. And some of the key capabilities related to energy management include out-of-the-box energy analysis to monitor things such as compressed air, electricity, water, etc. Easy identification and analysis of anomalies and energy peaks. Flexible dashboard and KPI configuration with appealing visualization options such as charts, pie charts, gauges, etc. And it's built on a data model and the connectivity of Mindsphere, which allows us to use the same data and assets with all the Mindsphere apps. And lastly, as I've already mentioned, ISO 50001. This is a great foundation to give you the data and the evidence that you're getting a real good grip of your energy costs. So let's look at a theoretical use case, not an actual one we'll look at later, but a theoretical one for this technology and specifically related to energy management in a manufacturing environment. So we'll look at a typical manufacturing business here and look at it through the eyes of Susan here, who's our plant manager. She's got many challenges related to energy management. She's got to control and try to reduce her ever-rising operating costs. And she's got corporate sustainability targets to deliver on with a mandate to get ISO 50001 accreditation. But because she's got no granular visibility into where energy is used, she decides that she's going to invest in an IoT platform and monitor energy across all her factory assets. Without the IoT application, she only gets a very aggregated view at the facility level. So she can compare energy usage at a facility level compared to last month, last year, etc., but can't really delve into the reasons why things are changing, going up or down, etc. So by using the Energy Manager from Mindsphere, here's some typical screenshots from the platform, showing some of the views on energy usage that can be used straight out of the box once the assets are connected and the data is flowing into the platform. Susan now gets immediate transparency across the whole factory, and she can now see where and when her energy is being consumed. And it gives her the ability to do deeper analysis on the data using some of the more advanced analytic tools in the platform to make even more insightful decisions. The dashboards immediately highlight where savings can be made and the size of those potential savings. In this example, Susan can see when she's using energy, but not producing anything. And this will prompt her to have focused conversations with the right people in her team about why this is happening and to take action. Previously, with an aggregated view of the energy, this insight would not be available, and it's highly probable that no action would be taken. So this is great, Susan says, and she tells her colleagues that are running other factories within the group about the success of the platform that she's had. And because it's cloud-based, the solution can be rapidly scaled out across the whole enterprise so that the savings can be realized across the whole group. So I'm going to hand over to Andy now. He's going to step into the application and show a real view of it before coming back to the slides to take us through the case study for a brewing company. Over to you, Andy.
Thanks, Gav. Good morning, everyone. So as Gavin said, I'll take you quickly through the application just to show you what it actually looks like. And then we'll walk through a case study of how the application can be used to solve a real world problem in a brewery. So what you see on screen here is one of the dashboard visualizations where we have electricity and heat energy mediums being visualized with a trend. Now, this data that's captured is from a demonstration unit that we have with a temperature sensor and a potentiometer with voltage. So yesterday, this was switched on for a period of time, and I can clearly see the consumption of energy for the potentiometer for the voltage, and I can clearly see the heat as well. So this then calculates up to show how that consumption is in terms of costs, and that is also calculated in terms of CO2 equivalent. The way that is done is by using the energy provider. So this is just an example, but if it was a business with an energy provider's contract, you would plug in the cost of the kilowatt hour and the CO2 rating for that kilowatt hour, and it would automatically calculate based upon the variable use of these energy mediums. So you can very easily see the difference in energy. So what we also have is the ability to drill into these and see these in a little bit more detail. So we've got electricity there, as you can see, and we can look at this from a line chart. We can look at it from a bar chart. We could also look at it from a histogram perspective. So you get lots more statistics to drill into these in a little bit more detail. On top of this, you can drill into the energy details in a little bit more detail with a custom dashboard. So what we have here is a custom dashboard that can show the energy cost rated for the day in pounds, and also the electricity use for that period of time as well. And of course, you can see there the factory temperature, which could come from a sensor in the factory. And we get the hourly average of that temperature over time. This dashboard could be constructed by anybody with a little bit of training in Mindsphere to create something that matters for their area or for their particular insights that they require. The energy distribution here is shown from a Sankey diagram. So what we can see is the total consumption, and that's broken down in this way simply between electricity and heating. Now, furthermore, what we can do is look at this from an industrial context and how electricity or heat or other energy mediums are divided across different assets. So an example of that is shown here in this dashboard, which is looking at a building with a number of different assets. Now, if I select the period of time where the data has been provided, we'll be able to see a number of different assets where there is energy consumption. So here we've got a FANUC, we've got a Thermotron, and we've got a Mazak, 3 example machines, robots. And we can see here the total consumption for each different type of asset, but we can see that also broken down by the different energy mediums. So you get a clear insight into what the biggest consumer is, but then also which energy medium is the biggest contributor to that consumer. And this is easily customizable to suit whatever energy sources you have. So what we'll do now, we'll take a look at the actual case study for using this application. Okay, so what we have here is a brewing process that consists of several stages, and the brewery handles several complex process steps before finishing the beer produce, which is filled in bottles at the end. So the water is purified, it's mixed with malt, liquid is separated, and hops are added, etc. And then finally, the production goes to fermentation tanks for a few days or weeks, following which it is filled into bottles. Now, in this example, the production of one bottle requires 0.25 kilowatts of electricity, or almost 2.5 pence, assuming average industrial electricity prices. Now, I'm sure that will be a lot more in this day. Now, the energy consumption contributes to a significant share of the product cost. So it's great to get this insight and be able to see how changes might allow this cost to come down. Now, in addition, increasing consumer demand for these products, for sustainable products, should I say, creates a motivation to find ways to reduce these energy costs. And in some cases, breweries are achieving zero or even carbon negative status using these approaches. So here's a high-level look at what the steps might look like to address the energy cost challenge, and how the platform can help provide the insights and support these steps. So first of all, we've got a plant manager who has a factory overview dashboard. So the plant manager, after seeing the electricity consumption is out of range, it allows her to get an overview of energy usage and a look at the predefined energy KPIs in order to react if they go out of range. Now, it's possible to receive emails or push notifications with warning limits of when particular areas of the factory or devices in that factory, in that brewery, are exceeding a particular threshold or limit. So the plant manager, using this information, when she sees a spike or an out of limit condition, can speak to the production engineer and ask them to investigate why electricity consumption and therefore cost has gone up. The production engineer is armed with the ability to look in more detail and use a regression analysis tool to analyse the brewery process and see where there's relationships between the data sets. Furthermore, there's additional visualizations to carry out more energy media analysis. By looking at the lines across the day, you can spot a recurring peak of electricity consumption per bottle produced. And he uses this comprehensive analysis function to investigate further. So after getting clarity on the circumstances of the recurring electricity peaks, he can set up a discussion or a meeting with the shift manager to discuss how they might be able to be avoided going forward, armed with the evidence that he has in front of him on the dashboard. So looking a little bit deeper into this and each of the steps associated, the factory overview dashboard consolidates all energy usage into an appealing way. This allows the plant manager to check for further energy flows and react immediately if the spots any KPIs out of range. So the Sankey diagram gives an overview of the energy flow, as you saw earlier, and highlights the brewery process, which is the biggest consumer of electricity. The heat map shows the energy consumption over the day and which periods of time are the biggest contributors to the energy consumption, when energy is being consumed the most. And then finally, if you look at the energy consumption itself per bottle, you can see in the yellow area where that particular energy consumption is, and ask your production engineer to investigate because it's above the nominal or ideal range. So really simple insights to trigger these actions and investigations. The production engineer, using the regression analysis tool configured, shows the relationship between the number of bottles produced and the electricity consumption. He observes that the dots which represent the electricity consumption for a batch of produced bottles are scattered plus or minus 20% along the regression line. This is more than he expects, and it shows there's a significant variance of energy required to produce certain numbers of bottles. So the conclusion from this is there's an opportunity to stabilise the process and reduce the amount of energy consumed. The energy media analysis tool shows the electricity consumption and CO2 equivalent and cost for a specific process within the brewery over a period of time. After finding deviations in the regression analysis earlier, it now checks at the electricity consumption for all processes to see which one shows anomalies. So from the Sankey diagram earlier on the factory overview dashboard, he knows that the biggest consumer of electricity are the chiller, mixer, and purifier, but they do not show the anomalies, simply that they are the biggest consumers. However, looking at the electricity consumption per piece produced at the filling line, he spots an abnormal spike. So the filling line is now the area that could be the anomaly that's causing this increase in energy consumption. And this spike occurred on a particular time, in this case on the 6th of December at around 7 p.m. So he wants to look further into this and see what happened on that day. So he changes the view to show how many units were produced each hour via a bar graph, and hovering over the period of time where the spike occurred around 7 p.m, he can see where the peak occurred, but he also sees that only 16 bottles were produced and none in the afternoon. It turns out that the filling line was ramped up after the cleaning break in the afternoon in a suboptimal way, and this can be observed on other days as well. It's a continual pattern which occurs whenever the filling line is ramped back up. after a period of non-use. And you can clearly see that on this diagram here. So next, armed with all of this information, the production engineer plans to set up a meeting with the shift manager to discuss how they can improve the ramp up and avoid these peaks in energy use. Using Mindsphere, they can explore more apps in the platform to aid the improvement process and arm the brewers or the production teams with information themselves about the impact of ramping up the brewing process on the filling line, but also about the energy consumption that's occurring at each period of time and at each process during the day. By having all of the assets connected to IoT platform, the team have easily shown and identified a solution that unlocks the potential to deliver on their commitments. If they continue just reviewing aggregated data at the facility level, then these marginal gains would not have happened in any way. So from this exercise, the brewery can start now reducing their energy costs, and they can also use this application to explore other areas of the brewing process and optimize those brewing processes to reduce the energy costs. So that's the walk through the case study. We're now going to take some time to answer any questions that you may have. Over to you, Gav.
Thanks, Andy. So please, I probably should have mentioned this right at the start, please enter your questions in the chat. Alison, who is from our marketing team, will moderate those and pass them on to myself or Andy. So we'll give you a couple of minutes to get those in, and we'll be happy to give you some feedback.
Okay, so we've got our first question already, which is how can it be easy to connect my equipment?
Yeah, so I'll take that one. Yeah, the connectivity is really important question because it unlocks the ability to see all of the data. Now, there's a number of options here, and typically if we're talking about industrial assets such as the brewery process, using programmable logic controllers with industrial protocols embedded. There are industrial gateways, which are effectively powerful industrial computers that can be used to securely connect to the network of that piece of brewery equipment or asset. And with this, we can tap into the data points to pull in, if it provides the energy values provided from the PLC. If not, there's the option to pull in things like current and voltage use and calculate the energy use using those variables. Now, it may be that you don't have that PLC, you don't have that type of sophisticated equipment, and simply you might want to capture the operation of a piece of equipment when it's on and when it's off. And by knowing the load that it pulls, you can calculate its energy consumption. So that could be done by retrofitting sensors. It could be done by adding smart plugs. Either way, there's a range of options through industrial gateways, through sensors being retrofitted, through smart plugs, current clamps, to capture and calculate energy use from a range of different assets and devices. And all of this can be done to securely send data to the cloud to provide those dashboards and insights that you saw earlier.
Thank you, Andy. Any more coming in, Alison?
No, I think that's it for today.
Okay, that's absolutely fine. Well, with that, we'll thank you once more for taking time to come and listen to the webinar today. If you do have any questions or you want to find out any more about Mindsphere in general or energy management in particular, please do get in touch. Send us a message through LinkedIn or on our emails. and we'll be happy to get back to you and have a conversation. And with that, we'll end the webinar. Thank you very much.
Thank you, everyone.